Another way to calculate distances and differences in similar figures is to use what we call the internal factor method. And it's similar, no pun intended, to the scale factor. But this time we're actually using a proportion. So in this case, we are talking about the relationship between the height and the width of the model, and that is proportional to the height and the width of the actual sculpture. So here, what I've done is I've set up a proportion, 20 inches tall, 10 inches wide. That represents the distances on the model. And here's the important part. Because 10 inches is wide and 60 inches is wide, we need to line them up on our proportion. So since 10 is on the bottom, we need the 60 to be on the bottom. We could write it the other way. We could write 10 on the top and 20 on the bottom, but then we would have to write the 60 on the top as well. So the corresponding parts need to be in the same place, and that's the important part of setting up a proportion. Now, to solve a proportion, you may remember back in another math class that when we have a proportion, what we can do to solve it is we can cross multiply. So here in this case, we say 10 times question mark equals 20 times 60. So 10 times question mark is equal to 120. If we divide both sides by 10, we get, 1,200. I didn't do my multiplication correctly. And then 10, so we divide both sides by 10, and we end up with our final answer of 120 inches. So all that to say that in the internal factor method, what we're doing is setting up a proportion between the height and the width of our model and comparing that to the height and the width of our actual sculpture.